Okay, I hope you all can hear me well. Really happy to be here and welcome to the Rapid Pipeline Unreal webinar. But first of all, let me just open up this presentation here and walk you through from the beginning. And yeah, I'm really excited to be here and present to you our product on the Unreal side. Just very quickly overview of who we are and what we're doing, and then basically jumping into a little bit the agenda, what we want to cover today. And yeah, then always open for questions. We have a whole team of moderators basically and panelists here, which will support me behind the scenes. So you feel free at any point to ask any questions, and we're of course trying to get them all asked. I will actually reserve a section at the end to also jump on any open questions which are not answered yet. So basically there are two ways to answer. You get an automatic answer from a secret DGG panelist basically, or another member in the webinar. And then there will be the reserved section at the end where I can also weigh in on certain topics directly on screen, basically. Yeah, that said, very nice to be here and thanks for joining this webinar. I'm Julian, co-founder and head of 3D solutions at DGG. So I'm with our company from the beginning, and our product is RapidPipeline. It's basically a feature, like a tooling, overarching tooling for 3D data processing, data preparation, also 3D optimization, anything with LODs, anything game ready. And of course, that will be also part of the webinar today to get assets more like real-time experience ready. This is basically our expertise. This is what we're doing for almost 10 years now as a company. And RapidPipeline basically offers all these solutions for a lot of different tooling as plugins. There will also be our own studio desktop app coming out this year. And we also have a web-ready optimization pipeline or data management layer, let's say. But yeah, today it's all about our Unreal Engine plugin and basically the interface and all the options you can have in the realm of 3D processing is the same in all our plugins. So if you're interested maybe in a Blender instead or in 3ds Max plugin, we also have webinars already out there on YouTube by the fantastic Eric Chadwick, our colleague here at DGG. And yeah, if you have any interest in other tooling, things we maybe not support yet, Cinema 4D, etc., just shoot us a contact email on the website, rapidpipeline.com. We're always happy to provide our plugins and improve and put them into different DCC tools where needed. The focus today will be a bit more on the CAD side as well. So importing CAD data, performing tessellation, doing all the data preparation steps in like a semi-automatic fashion so that we can quickly start working, maybe even directly in Unreal assigning materials and getting started with raw CAD files, just getting them into the engine. Yeah, again, that's me, the company for a long time now, and happy to answer all your technical questions as well. And yeah, here a little bit about RapidPipeline. Again, a little bit repeated what I said before. Lots of 3D processing features, not only optimization, not only like screen size optimization, as you can see on the left side, but also, for example, raycasting based, occlusion culling, auto UV mapping, UV unwrapping, baking processes, decimation, of course, remeshing, and our newer CAD features now with where we support 60 to 70 new CAD formats, and then we run a tessellation on them, but I have a bit more information on that soon. Basically, the plugin layers, they are all performing interchanges right now within the different DCCs. So example, for the Autodesk suite, that's FBX. For Blender and Unreal right now, that's GLTF, but that's definitely something we can base also on different formats going forward. So USD is one which is super popular right now, definitely a format we support already, and could also be used as an interchange layer here, of course. Yeah, so today I will go basically over all the options on the import pipeline in terms of CAD data, a few little tricks here and there you can do, suing of the BRAP patches coming from CAD. Sometimes that's really helpful. For example, automotive assets, which usually come up split in a lot of different smaller patches. And it's sometimes a bit tough to then merge the vertices by distance or do some kind of post-processing operation like that. It's a bit like editing a JPEG on the 2D side. You don't really want to do that. You want to actually fix that on the BRAP, on the parametric solid level before actually doing the tessellation and then having more clean vertices and clean connections. But yeah, we're going through all these features live in the plugin. Tessellation, on the tessellation side, we have a lot of options. That's actually something I'll go into a bit more in detail in the demo section. But yeah, we have all options in terms of the density. And I think I also have a slide, a little bit more information how we actually do it. This is all visible in our documentation, so it's a bit more in depth how actually tessellation settings work. But yeah, I'll go into detail a little bit further down the webinar now. Features like repairing winding orders, I think this is something we're doing then on top of the tessellation, on top of just the CAD conversion. We have quite some features also dealing with bad geometry, bad winding order, flipped normals, and so on. So we have cleanup operations handling that. And at the end, on the automation side, these can, of course, be ingested all together into the CAD import directly, that you can make sure also within the batch processing, for example, that you always correct the winding order, for example. A few more lesser CAD-related features, just wanted to call out as well. I have a quick demo for that as well. We might skip over these types in this webinar as it's not 100% related to the CAD import use case, which we want to mainly showcase today. But yeah, if you guys are interested, we have imposterization, and yeah, I can also give a quick demo about that. Same with remeshing and the baking pipelines. Occlusion culling is an interesting feature as well. Works well on, of course, imported CAD data, but also on other 3D data. Here, for example, this microwave assets. Yeah, we'll have a look at that later as well. There are some features in development, something unfortunately we cannot show yet live, but that's really exciting stuff coming this year, actually. So we're working on a full waterfy support, basically. So a lot of times from the tessellation process, we already get usable edge loops, which is sometimes really helpful for manipulation and last minute changes. Might not be 100% relevant in Unreal because, of course, it's a game engine. So we're tessellating, we're having triangles anyways. This is maybe a bit more important on the DCC side, right? When we have the same kind of plugin interface, the same processing options in Maya or 3ds Max before we actually go into Unreal. And there you have an easier life manipulating the, of course, when we have at least quad dominant topology. And then, of course, hole filling is an interesting feature. We received a lot of requests for that. So it's basically what you sometimes also call defeaturing, and basically identifying topological holes, which are basically intricate parts of the actual mesh, and not just like a missing face or something, right? That wouldn't really count. And then we are able to basically fill these holes up, basically being able to then easier tessellate or optimize the assets. Of course, we could bake the hole also in a texture map, even a normal map on the new surface. It's a little bit a niche workflow, but sometimes for really smaller holes, you don't really want to deal with on the topology side. It can be really helpful. So that's something which is in development at the moment. Then let me just jump into the demo side. We will basically start with a simple CAD import and having a look a little bit at the options. And then we will go step by step through the chain and options of tools. As I said before, we will not be able probably to cover all of it. So we have a lot more tooling than I can cover just in this webinar today. But if you have any questions, anything I can maybe still show while in the webinar, just let us know if you have any further remarks here. All right, then let me exit the presentation here and basically jump directly into Unreal. So this is a sample scene, and some of the assets I'm using are actually in our documentation, which looks like this. You can access that documentation directly from our website, and we have a whole tutorial section starting with, of course, the installation of the plugin and how to get it running. There's a free trial, of course, as well, free pro plan trial, so you can test it out completely, install it, and then just get started in our tutorial section and go through step by step the functions we have already. So here in this example, we're starting with a certain coffee machine asset here for doing the CAD import and then switching back from SolidWorks to Unreal Engine, for example. This is all the stuff you can also look at your own pace. And some of these assets I will showcase today and some of the features. Yeah, but there's definitely also a resource you can use besides this webinar. Yeah, we have a look at the very basic scene here, right? So we have just scaled the standard plane a little bit. And I prepared, of course, everything already in folders. There are certain assets which take just a little bit longer to import. So I will focus today on just demoing the CAD import on a bit simpler asset. So for example, I just imported this guy here, which is a generator coming with quite some nodes. Unfortunately, this is more like a more simple asset. It doesn't have an intricate node structure. We can showcase that on a more complex model. And what you basically get when you use our plugin, which is the interface, and what you get when you perform an import of an asset is that you get one version populated already into your scene and into the outliner as well. So in this case, it lives under the folder I created, but it would otherwise just show up in your outliner and your scene graph. And it always, of course, has a root node, a root actor, and then it has either directly meshes under it, like in this case, or if it has already an intricate hierarchy, intricate scene graph and parent nodes on the cat side, or even on the FBX or whatever the format is you're importing, then we can of course preserve that and the naming and everything and display the scene graph right here. The other thing is that it doesn't only populate in your outliner. Of course, in order to do that, as you might know as a Unreal professional, that of course your data also has to live on the disk, basically on the content browser. So the usual more old school workflow, of course, would be to load a model in the content browser, check it up, go to the mesh tab, go to the material tab, prepare the model if needed, and then you drag and drop or add it via a script or any blueprint automation into your actual scene. In this case, we basically did a little bit double dipping here and do it in the content browser as well as in the scene. So automatically, basically. This is a little bit similar to how I think in Unreal also normal import would work, or like a datasmith import for CAD files. So we oriented ourselves like to that system. We think most users are familiar with that. So there's a folder. In this case, by default, we just call them imported assets. And basically that's where that asset also was saved. So here, generator, and if we go into it, we have the scene actor, we have the static meshes. In this case, they're all combined, so that there's a bit more to that. They're not combined, they're all separate. We have options to actually merge these meshes by a certain metric as well automatically. So you don't have to always have this massive assembly of parts. Of course, we build it up for you in the outliner automatically, so you can still manipulate the asset as one. But if you really want to, for example, just do a quick material assignment and say, okay, this pipe part here of the generator, maybe share the material actually with the other part down there. And maybe you just don't want to drag and drop too much of materials and just want to have them merged. So that's definitely possible. Yeah, on the material side, we support basic import for CAD materials. I think this is an XT file. So there we have it listed in documentation as well. You can look that up online, where we also list where we support materials in certain formats and where not. So right now, I think Step and 3DM from Rhino, XT, a lot of the SolidWorks assembly and part formats, all of that will support basic material colors and of course also the naming of the materials. And then you will be able to basically get them inherited here. And we can work with that. We can bake these into texture maps automatically. We can do a lot of things with them. But yeah, usually these are fault colors, right? Usually they're kind of stand-in materials, just ready to be replaced, let's say. But yeah, just I think it's good to know we support that general feature. One thing maybe which is coming up later in the questions, but I want to address it right now because it is on the general side of the CAD import, is that for certain formats, we support actually instancing. I think one of them is Step, but that's something we basically didn't focus as a main feature point right now. Definitely keep your eyes open. We will working on an update here to have a focused support for instancing coming as well. I think certain formats where we don't support it yet. And as I said before, we have this data exchange layer. Right now that's GLTF, and GLTF luckily supports instancing. So that's something we definitely are supporting. But it might not work for certain formats. And that's something we're working on at the moment, and we'll clarify also in the documentation. When does it actually instance things and when not? So on the actual import side, so I just showed something basically pre-prepared. If we want to import something like a CAD asset, we have a function here directly in the plugin. We differentiate between the import plugins, actions on the import side and on the export side, and then on the processing side. And so each of these tiles is basically called an action and will perform a certain process. On the import side, basically, if we just have a look, I have some content here, which I actually used in the preparation process. I'm just pasting the link here. And there's our generator, you see here. And if you just import it automatically, you don't have to specify the model. You will always, of course, see the files populated, which the app supports for import. You will get a pop-up here, and you just have to increase the scale here a little bit to see what it is. And you can choose between CAD import and 3D format import. Technically, they're both the same. but they expose different settings, meaning if you accidentally have the import 3D format open and import a CAD file, it will just import with the default tessellation settings, so it will not break anything. Similarly, if you import a normal 3D file, FBX file or something tessellated with the CAD settings, it will just run the default import settings. It's more about the settings we expose here. So for the CAD side, you can really dive a bit deep into the tessellation algorithm, how that actually works. You can select a preset we offer right now, or you can select a custom tessellation, and then you can steer basically the whole tessellation process with further settings we have. So for example, we have a value for max surface deviation, and that's also explained in detail in the documentation. The max angle of the tessellation when actually trying to fit and basically project the triangles on top of the parametric surfaces, the freeform surfaces, and then also max edge length, which can help with if you have very large flat surfaces. And as they tend in a tessellator, they tend to be populated with like very long, thin triangles, depending on how the curvature is, where you have holes and features where you have a lot of vertices, right? You have to connect to, and to avoid, of course, n-gons and so on, you will have thousands of triangles there. But with that feature, max edge length, you can say, hey, these triangles, of course, they consist of edges and they have a limited allowed length, meaning that you can basically place almost like edge loops in the middle, in the best case, right? In the best case for the tessellation, and basically decrease the length of these features. So that this is usually very helpful for shading or other workflows which really deal better with the more heterogeneous topology rather than homogeneous topology, rather than a very heterogeneous one where you only have like really high tessellated corners and very flat surfaces, which is in itself also not bad. But sometimes you, especially with the mesh normals, you might run into problems. So this can help. We have other settings such as removal of T-junctions. This can be really helpful. It will actually add a few more edges, right? So it's not in that term like a optimization step per se, but it's an optimization step in terms of the actual vertices positions and how they are connected, so that we are not running into non-manifold issues and T-junctions, open missing triangles and stuff like that. But that can happen a lot with tessellated data, as you might know. With the removed T-junctions, we're adding a few helper edges and actually have a more cleaned mesh. This actually helps a lot also with UV projection at the end. Yeah, nanite is always a question. I think for my presentation, I actually turned nanite off. To be honest, the only tests we did on our end with nanite were not really successful in terms of usability on CAD assemblies. We got way better results with traditional LOD approaches. If it's our LOD side, right, on our decimation side, or if it's the old school Unreal LODs. So far from our testing, nanite worked really great for more homogeneous distributed meshes, such as 3D scans, large environments, maybe even like height map projected environments. So yeah, I'm not sure if that answers the question, but yeah, from our experience, it's a bit annoying, of course, to create all these LODs then in a way, but we also have tools to help with that and would recommend more the traditional side of LODs. But yeah, I need to double check if nanite ran an update where they're a bit better with actually intricate geometry rather than environmental meshes. Is there a file size limit? Technically not. So the plugins actually run locally. So there's no file upload, download anywhere. So we have a cloud platform, yes, but that's more like a kind of a demo and first steps. And the actual file size limit should be whatever we can take. Let's say it like that. We've seen, I think, tessellate results from up to 250, 300 million triangles. We've seen cases like that. But yeah, so there in general, no, there's no file size limit. Oh yeah, that's a great question. Let's jump right into it. Yeah, for CAD data and Unreal. So for example, if you're working on something like an interactive product presentation, a quick rendering for marketing purposes, or even a configurator application, I have to say for the last one, the configurator side, it is actually usually more common to really have a whole cleanup and a bit more intricate pipeline workflow in another DCC, usually, right? 3ds Max and so on, to clean up the mesh and everything and make everything like rename nodes and stuff like that. What we are enabling with this plugin is that you can take some of these steps directly into Unreal. So I can give you a quick example. Let me see if I can show that just a little bit. We have the different tessellation solutions. That's something I wanted to show anyways, and then we can jump directly into this use case and topic as well. So yeah, as you can see, we can go from the presets from very coarse to all the way to very fine and have then a more high resolution distribution of faces. And then the one here on the very left side, these two here, the other ones with custom tessellation. So I just increased the resolution on the custom side a little bit, something I just showed before. In terms of use case, basically having the CAD file directly imported, and there's the option also to create auto UVs, for example, on that. You can basically start applying materials directly on the CAD data, right? So you can directly have some very simplistic materials. Here's a version. That's maybe one thing which I wanted to show now, which could be helpful with the material assignment. So on the one hand, we have an import where we just, as I showed you before in the content browser, with having all the different single parts where they all populated in that original scene structure from the CAD file. So there's a lot of stuff to deal with. And if I start, for example, just making a very quick kind of material study, right, and go here with a window, it can take a while to just apply this, right? And especially then if you don't have instancing here on the screws, like applying a material to every screw, it's really tedious. So if you have a really kind of visual workflow, and I hope this also goes a bit into that other question we heard before, just preparing a real world scenario where we have maybe a showcase of this car model here. I imported this file and you can see that it's having a whole part merged together. And I imported this file just ticking the merge by material option, basically. So basically, if I just apply, for example, this material, it actually applies to the whole car body because on import, we were merging it automatically. In this case, by material. So it depends still on the file structure of where the asset is actually coming from. So if the body would not be in a great shape in the first place, then the whole kind of merging action might not work perfectly. But you know how it is. It's always depending on the actual quality of the input data. But there are a lot of features which are basically worked here under the hood. There was a winding auto correction. And I'm also going a little bit into the sewing process with the next demo. So yeah, in terms of the use cases, this is one of the very simple ones where we can just go ahead and actually make this, let's call it visualization ready directly from CAD. So if you happen to work in a corporate or company environment where you actually have in-house products, you have to have a marketing department, you have to advertise something, you maybe even working with Unreal, there's a project for a car configurator, or even we've seen that even with kitchenware, right? Walkthrough use cases, there's floor planning, even for certain home appliances brands, they have internal VR-based workflows based on Unreal Engine to showcase the manager how the actual new fridge XYZ microwave looks in the new presentation space and so on. And of course, this is more true for high-value products such as automotive and so on. But we've seen that as well for home appliances. And having the option to just directly ingest the engineering data, maybe even in the design process or even in a more earlier stage, can be really helpful for these use cases. So yeah, I hope this answers somewhat the question, at least partially. There are a lot more use cases you can think of in terms of getting CAD directly into Unreal Engine. And again, it's not now like a super high quality quad-based retopology. That's actually something we're looking at the moment. And for certain use cases, you might want to have a prep step in a DCC before actually going into Unreal. The plugin is actually supported in Unreal Engine version 5.6 and newer. And we actually have installers now also for 5.7. So we just updated that. And yeah, we're trying to always follow up with the latest versions. And of course, we also have to build a new binary of the plugin, but you should always have it available. And if you want an older Unreal Engine version, 5.4 and so on, just let us know. We can definitely provide these builds as well. Shouldn't be a problem. If we go too far back, right, Unreal Engine 4.6 or something, it might be that we run into some compiling issues. There's always no with software. But yeah, we were happy to accommodate for that. Yeah, the group structures that's actually a good point. Basically, we try to translate the group structures as good as possible. I think we got a recent feedback specifically from Rhino that there's one specific concept, which I think is called configurations, if I'm not mistaken, which we're currently not supporting. So yeah, if you have a very specific feature you're discovering in the app that you cannot port over with our tooling, it would be really great to open a ticket, let us know, and we will have a look at it and see if we can support that. But I would say generic node grouping, and then of course translating BREPs into the children nodes as meshes, that's for sure available, and general naming conventions as well as the materials. But I think right now we are not looking at other features than that, and also not necessarily looking at the actual CAD metadata, right? If you have metadata in the app referring to like data which is not directly related to the 3D content itself, but it's maybe the weight, the price, physical properties, that's something we are currently not piping through. Yeah. Just testing based on relative object size, so that's small objects. I think that's already answered. Yeah, so there are all kinds of ways to adjust the tessellation based also on object size, bounding box size per part. So that's basically in these presets we have from coarse to fine. They're already taking that into account. And in the custom section, you can actually have the deviation part going as well. So let me just pull this up just a little bit.
Yeah, one thing I actually just jumping in here. This is Eric Chadwick.
Thanks, Eric.
One thing I noticed is generally that it's great to just import it as a nice fine resolution for the tessellation and then let the 3D processor or RapidPipeline do the decimation, because then it's really smart about how to preserve detail. For example, if you look at the roughest tessellation version of that car, it's super blocky and chunky. You get down to, I think it's like 400K or something triangles. But if you import at the highest resolution and then tell RapidPipeline to actually do the decimation, you get a really nice result. You don't get all that blockiness because it's being aware of curvature and it's adjusting the model based on deviation from the high-res source. Whereas when you're just bringing it in at the lowest tessellation, none of the algorithm's just not aware of that. It's taking each patch and trying to figure out how to tessellate that alone. Anyway, sorry to interrupt. Just wanted to.
Yeah, exactly. I think that was the resolution question. Yeah. Triangle count we can go to. Yeah. So in the finest tessellation resolution, so in theory, you could go to custom and then say you really want I don't know, picometer, like really 0 point something millimeter for the actual resolution deviation from the actual parametric surface. I would say open end. It really depends on, I don't think we currently have an upper hard limit on the triangle count, how much is generated. It really depends then also on the DCC, in this case on Unreal, how much it can handle. Yeah, luckily with Nanite and all that stuff, like it shouldn't be necessarily a problem. Again, I think that was the question from before. We see that especially with Tesla CAD surfaces, Nanite might not be the best solution at the moment, but I'm sure that there's a great team also working on that. So yeah, in a way, open-ended, we've seen up to about 200, 300 million triangles in a single file before. It really at some point is then about performance and where does it make sense to stop. I think we have reasonable defaults already on the resolution side, on the tessellation. And yeah, basically, yeah, if I double check here, let's say it like that, because they're based on millimeters in terms of the presets as well, what you get with a very fine, or in this case called extra fine resolution, is already on that level that you shouldn't see any blockiness anymore, even in the smallest screw or detail. I mean, if there's still like an edge case, you can still go to the custom resolution and really go very low in terms of the surface deviation, really being very close to the original parametric surface. And then you should actually get a good representation, a lifelike representation of the actual parametric curvature and everything. And yeah, thanks Eric again for jumping in. I just did, as you can see, more or less instantly the decimation here. Again, we have that feature. It preserves the normals. It can preserve topology. It preserves UVs if there are any in terms of the UV mapping. So yeah, that's not a big deal. Can you talk a bit more about the UV mapping? Yeah, so the UV mapping, I would say it doesn't make too much sense. Please comment or correct me if I'm looking wrong at this. But in Unreal itself, it would be great to actually have the mapping and the materials already done, or like kind of a LOD0, let's say, right, as an input model. And then we can go from there, and we can also rebake it and create automatic UVs. But there is a way, so you will have actions here like the generate UV Atlas action, where you have quite some options how we actually generate UVs, how the islands should be. Should they be more organic, like looking at more on the unfolding process, the stretch? Should they be a bit more hard surface, so a bit more box projected and then packed? So there are options you can play around with if you want to UV directly in Unreal. However, I bet it's somehow possible to have a texturing workflow in Unreal and create UVs and then somehow fit the textures to it, but usually would do something like that in Substance Painter or something, where we also have a plugin actually to work on that. And yeah, Eric, I think also can jump on that answer. Yeah, we also have tiling UVs. So that's maybe something interesting for if you want to have some procedural material, which is definitely possible in Unreal for sure. That's something we can always generate. And these are basically box projected from 6 sides, and then they're basically overlapping. So they're not great for like actual texturing, like throwing a texture map on it, but they're amazing for procedural materials. You can try that out. In terms of microns, I have to be honest, I'm not sure how low we can go. So the actual, let me see again, I have it here, the settings. So this is in millimeters. So basically our internal default for very high resolution, even higher than the extra fine, would be 0.01 millimeters. But I'm certain we can go further than that. But that's a question I would like to refer to maybe a colleague or after the seminar, after the webinar. I'm not sure how low we can actually go, but we can definitely go way further below the millimeter scale for sure. And yeah, this is actually the deviation as well in terms of the difference between the tessellated surface and the B-reps, basically the solids. Yeah. All right. Yeah, then maybe I'm jumping to the actual next topic, and on the panelist side, please let me know in the back end how I am with timing, because I think we might run a bit over time already with all these great questions, which is it's a good problem to have for sure. The next thing I wanted to show is what are we actually doing on top of tessellation, right? So we know that Unreal also has the Datasmith importer, and it does a basic tessellation as well. It has also certain settings. Yeah, from our benchmarking and experience, of course, we have a few more settings, a few more customization. Yeah, the webinar will be recorded and will be available on YouTube. Yeah. Thanks for asking. So yeah, basically we offer that tessellation piece on the import side, but we also actually are doing a little bit on top, which we at least have not seen in the Datasmith and in other apps generally. Not yet, at least not the ones which are working inside Unreal. So I have a little demo here for the actual swing, and it's a very simple example model. It's just a door trim. And let me see if I can actually maybe just assign our material here. It didn't work so well because I think the winding order in this case was also not corrected. So this version is just a raw import without any additional settings here. But what I can show you is that some assets, and that's what I mentioned before, especially from automotive, will come with all these little separated pieces here on top of all the other issues you might have with the tessellation, you might have with the winding order and other problems. And this can be somewhat annoying because ideally, you want certain separation of parts and maybe even of a more larger surface in a way that it actually makes sense, maybe even corresponding to the actual construction data. But in this case, we have so many little intricate patches everywhere, which really can be a problem for any process down the line, right? Imagine now decimating this and we're ending up with all these gaps and duplicated vertices where they shouldn't be, or they should actually be merged. Now, as I said before, we can take this, select this, and have a vertex merging by distance, which we actually offer. We have a cleanup mesh option where we can do that. But as you might know from other tools like Maya, where this is like a common workflow, it's invasive, and you start when you merge the vertices to also lose the actual mesh normal information. So it's really not where you, as I said at the beginning, it's more trying to cut out layers of a JPEG and make a PSD again. You don't really want it this way. So therefore, there's a way on the import side to do that, basically. And let me just do this again. So we have just very few little Boolean settings here. You can just check mark them at the moment. And we, of course, can think about adding more settings to this. Of course, with these actions, we try to be as concise and simple as possible. So they have a lot of automation, a lot of kind of expert settings on the backend, but we try to get the best defaults for you guys so you can just select the automatic function. So for example, there's the winding order correction. For example, there's what I wanted to show here, the swing tolerance, which is also in millimeters. And right now the default is 0.05. And basically what that does is on the BREP level, it already sews the solids together so that on the tessellation process, we actually get clean vertices. And if we combine that with the T-junction removal, that's actually the best starting point for a clean topology. Of course, also in pairing with the actual surface deviation and resolution you want. And doing that on the door basically gives us a complete different experience, so to say, by basically merging all these parts together, right? And we still have differences in the topology, as you can see here, right? Like very flat surfaces with a low resolution. And again, we could steer this, as I said before, a little bit with the maximum edge length and things like that. So you could actually throw an edge loop here in the middle, basically. But you will basically get the vertices all lined up correctly and merged, and then you can run further optimizations on it, like decimation, without having the mesh falling apart completely. So this can be really helpful for certain solids with a lot of patches on the cat ingestion. I have another example for the actual winding order. So let me double check if I can see that. Let me remove that. So here we have an example with the default cat importer here. And this is a file where it really has problems with the winding order. And if I double check that in the Autodesk viewer, we go one step back here and I actually have it loaded. I think we can already see, and I'm aware that the Autodesk viewer I'm using here, just because it's very handy, it's very easy to show, might not have all the features which this file actually had in the first place. I think this is a 3DM file, so this has to come from Rhino. So I'm aware that the Autodesk viewer itself also might not have it's not the best software to preview this, but at least we can see also on the BRAP side, yeah, there are actually a few problems here, and it's not the perfect asset, which is great for our use case, because what we will get here, and this is especially visible in Unreal, I think if we would import this into Substance Stager or any other kind of DCC where we have a different rendering technique, and maybe we don't have double-sided faces or double-sided materials rendered, then we wouldn't even realize that we have a problem here with the winding order. And yeah, in Unreal, of course, by default, we want to do the backface culling also for performance reasons. And then, yeah, we get problems with this. And yeah, basically, we can fix that on import. As I showcased before, just a little check mark on the winding order correction was actually raycasting based. So it knows intricately what is inside, what is outside. It will correct the winding order. And then basically, let me see if I can activate it. So basically, this is the corrected winding order version. Again, it's not a perfect model, I would say, but it has now everything corrected, and we can start even assigning materials and yeah, going further with our workflows here. See, there's something maybe wrong with the normals. Yeah, if there's actually a flipped normal here, I think that was the case here as well. We can always clean that up with the cleanup mesh operation as well, which will actually recompute the normals. And you can actually have also like a normal angle. For CAD, we really recommend an angle of 30. That's basically the angle between soft shading and hard shading. And for more organic surfaces, which even could be like a chair, right, with some upholstery part, like a cushion or something, then we usually recommend a degree of 60 here. We also have the option to compute it per area or angle. That's actually pretty solidly explained in our documentation. Some of these are good for more cylindric shapes, but the default here is more suited for just a general selection of different assets. So we have it set by area by default. Exactly. 3D configurators. Yeah, that's a complex topic. Since you mentioned automotive quite a lot, it would be great to understand. Question is gone. I think it's already answered. That's great.
I was trying to help out with the answer. Like,
thanks,
basically, they were asking, why would we use this tool if I'm just if I'm a freelance 3D artist and I need to present stuff to clients? And I was saying, if you have any complex 3D assets that you need to optimize to work in a real-time way, then that's the basic answer. And CAD is a common problem there because it's usually badly tessellated. It's got too much detail in certain areas. It's got tiny little parts that you don't need that slow things down. So there's a whole bunch of things. And if you're using Unreal, well, it's all based around real-time rendering, and that has limits. So this kind of helps you solve those limits, basically fix things up.
Exactly. So I think in terms of we know how complex configuration use cases can be. And I think there's a lot of still workload to do in Unreal. For example, to set all this stuff up, you have blueprints, you have variant sets. Maybe you're actually be able to do the variant sets in USD and then have them actually rendered in Unreal, for example, or Omniverse for that matter. That is something we're looking at, of course, with a lot of interest. It's not something we support at the moment, but variant sets is definitely something we have in mind, and that would be really helpful for configurator use cases. But I think where we can help is actually the different assets within your configurator to get them directly into Unreal. And maybe you have a blueprint, you have a setup in Unreal directly, where it would help you to actually ingest, basically get faster to the target by ingesting the CAD data directly for presentation purposes. And as Eric said, auto-optimizing already the decimation I showcased before. That should already help. These are all kind of tools to get you there. But yeah, we don't have the ultimate configurator use case solution yet, I would say, but we're definitely are very interested to that topic. And also in terms of interoperability, we're big fans of GLTF. I think parts of our team, we even contributed to GLTF as a standard. And we're also following the OpenUSD development. And yeah, we're really open for standards. And this is how the plugin's already approaching it, right? You can open it in Unreal. It looks exactly like it is in Maya or any other tools we're offering. And we want to get to that point also with other functionalities and the 3D assets itself. Yeah. Batch processing is possible right now, not in the plugins, however. So in this case, you would need to actually re-import or import and tessellate another asset. But we have a command line tool which can fully automatically batch process and do exactly the same actions we're doing here in Unreal. That's on our on-premise offering. But maybe I foreshadow a little bit, but we're actually working on our, as I said before, on our Studio app. And the Studio app will have a little command line window as well, a little bit like the CMD window here in Unreal, where you can work with commands and blueprints and whatnot. And in that Studio app, you will be able to then write certain automations like, okay, import multiple cat data sets and so on. But yeah, in the plugins, it's more like a point and click workflow. It's a bit more close to how you would work on Unreal Engine anyways. Yeah. Going even further in terms of the features which are complementary to the CAD side, and let me see if I can actually show this here. Now we're in I think at a point where we add a feature set which also works for any 3D data. So we moved a little bit beyond just the CAD side of things, but basically we can support these features for any type of 3D asset or even existing part in an Unreal scene. These are very cool and very helpful. And some of them, for example, the occlusion color here is also very helpful, of course, for CAD data. And I can show you why in a little bit. This is a very simple example model, but this works, of course, on any larger file. I just don't want to send a whole process now on a large CAD assembly to let you wait too long. Let me put this on lid. So as you can see, we have a transparent material. We actually have a little pizza slice here in our microwave. And basically what we're showcasing here is the culling where we have a lot of interior parts. And again, this looks very simple. I think also this is not a CAD model. This must actually be a DGG from RapidPipeline, like a sample model. So it is just a demo piece, but it displays a problem we have a lot of times where we have interior geometry, for example, which is just not visible. And we don't have maybe time also towards that batch process topic to delete this manually or have kind of an occlusion object and put a collider in there or do the kind of culling process in more like an old school way, let's say. And instead, what we can do is we can just basically select the whole model, go in our actions and select the occlusion culling, remove occluded parts action. And here we actually have a few options and it's completely automated and raycaster based. So it actually knows where a face, is it visible, is it not visible? And it is transparency aware. That's pretty cool. So that's the demo case here for the microwave where we will not delete the pizza. So if I just run this by default, for example, I'm actually running this right now. This should take a little bit, but not too long as it's a very simple asset. And what we should see is that the interior parts in the actual solid parts and where we don't have any transparencies are actually removed. So we have the result here already. And yeah, the stuff is gone. And what you realize, it's completely gone. It's not just the triangles which were invisible. We can change that, but by default, our visibility is computed on a part level. So actually first it does a pass on the triangle side and shoots rays from all the triangles, right? It's a pretty cool algorithm. And then checks, hey, am I visible or not? And then it actually has a threshold here, which you can also change, which are right now like in the defaults, they're perfectly set in terms of working with most assets in a good way. And then it actually increases the selection to the actual mesh lump level, which I guess in Maya would be called shape. So it's not a mesh level, but it's what is the smallest coherent part of connected triangles. And it actually looks on the mesh lump level and then deletes those mesh lumps automatically. And as you could see that the pizza was not touched. Pizza is still there, everything good. So basically that helps a lot if you already have kind of an authored workflow. You already did your material assembly, perhaps in Unreal, and then you're running a culling process. But it also could be in reverse, and we even can turn this off. We can check the ignore transparency, for example, and say, hey, we actually want to remove that interior part behind there, because maybe later in the authoring process or in a certain material variant, we actually don't have glass here anymore, etc., etc. So that works actually quite well. And there's one more option, which is interesting for CAD, which is that we can do a per mesh culling as well. Meaning if you have a larger CAD assembly and each part has interior parts which might not be visible, but you want to have, for the configurator use case, for example, like an explosive view where you actually move parts out of each other, have an animation or something. And then it might reveal interior parts which are actually important to reveal. And this way, if we do it per mesh, we would actually single out virtually in the backend every mesh of this model and then only do the culling for each mesh. Of course, at the end, we have a lot less parts removed, but we make sure that for certain animations, rotations, and unveiling of certain smaller parts, these parts are then not removed. Yes, going into AI. Yeah, for sure. In that terms, we are thinking about 3D and AI as a pairing, and we're not thinking about AI as replacing 3D. We, on the technical level, are not super convinced that generative AI in terms of 3D is the way and only way forward. What we are actually looking at, and that's a topic for our studio app, is to enhance 3D workflows with AI, like not only background generation, but also like material generation and things like that. Actually working on that and using the 3D knowledge and the, let's, as you called it in the chat here, veteran knowledge as the basic term, and then adding AI on top to just increase the productivity and the getting faster to the design or to the production goal you want. Yeah, that's at least our point of view. Again, let's see what happens. We see it a bit like, yeah, in that way, a bit like what happened to rigging, right? When I went to animation school back in the day, manual rigs and stuff were the thing to do. You created all the intricate controls for your animators and do all that stuff. And then at some point you had auto rigging and everybody was like, okay, now I'm unemployed. What it turned out to be, a lot of my friends actually who are in the rigging, more on the movie and the VFX production side, they are the experts for rigging automation and rigging tools now because they know the process by hand. And we hope and think that this is the same way for 3D going forward. A little bit on the projective topic, never make predictions, especially if they are related to the future. Remember that. Yeah, removal of bevels is a very interesting question. That goes into the geometry processing in a way already. In a way, we can steer that a little bit on the tessellation level. So that is actually the, let me see which setting that is. That's actually a setting I didn't talk about much, which is the max angle, which is actually operating on the particular edges where you would do a geometric bevel or you would not do it. So in that case, you can at least steer the density of tessellation there. But I think right now we don't have an option to remove the bevels entirely and just create one edge. That could work in a decimation use case where we just throw a decimator on it to actually go from the bevel into a decimation. But that would be for us more like a invasive downstream workflow maybe. But it's a cool feature to think about. Yeah, if I go back, for example, let me see. Yeah, I created this one. Okay. Yeah, on the low resolutions, we already have more sharp topology. But at the end, yeah, as Eric Chadwick said before, on the tessellation side, you rather want to start with something high tessellated and then go on the decimation side, rather than starting with something really low tessellated, because, hey, there's no real cool way to go up in resolution and actually make sure that the curvature is correct and the faceting is smoothed out. As you might know, that doesn't work even if we would have perfect quad topology here, maybe, but yeah, in the real world, no way. It's a lot easier to start with something really high resolution and just go from there. Yes, so the CAD kernel, exactly. So it's not Parasolid, that's as much as I can say. It's a solid kernel which is running under other products as well on the tessellation side. What we did is we basically translated the settings in a bit more human readable form in terms of the surface deviation. And yeah, basically we're operating there in terms of communicating with that tessellation backend. So it's not that we wrote everything on the tessellation side ourselves. There are a few things we wrote on top, but not the whole pipeline. Yeah. And yeah, Parasolid, I think, is the reference one. It's, I think, one of the best ones, also from our testing. But we came to quite good results for the workflows we're presenting here with the different one already. And yeah, maybe that can also be answered in the chat from my colleagues. Yeah, but we had, I think, another one before. It doesn't come to mind right now, but we had some quality issues with that one. So we switched to a different kernel over the years for sure. All right. Yeah, I have a demo for the decimation, but I think we already saw that on this model here. I'm not sure if I was hiding it or if that is still the same one. I think I was hiding it before. Should be basically right next to this one. I'm entirely sure. I think I might lost it in my little bit convoluted scene here. But yeah, so in that regard, I don't think, unless there's a need here to showcase decimation again, yeah, we think of it as a very basic feature and can showcase it anytime. Yeah, we have a little demo here for the remeshing part. This might be interesting just because it's very quick and easy to showcase. So we have an asset here with actually like a fence with little wire parts. And yeah, as you can see, as a 3D artist now we really moved a little bit away from CAD, but I just want to showcase this a little bit here. From a 3D artist perspective, you would say, hey, why is this not just a plane and just projecting that stuff old school as a texture with alpha? And yeah, basically what it does is, you see, so it actually is a mesh. So if you zoom in here, yeah, this is a mesh. And maybe in a more abstract workflow, maybe there's even a CAD model coming with a certain mesh structure. I think we have seen something like that before as well. And basically what we can do here is perform a remeshing and bake holes. That's one of the shortcut actions we have. What it does, it shrink wraps the object. And in this case, it would make a square. I think the resolution I took here before recording was a little bit higher. So it's not a perfect flat cube, but it has a few more polygons here and there. But then it actually makes sure that this is shrink wrapped and watertight. And then it actually projects the holes into the alpha map. So if you just look at the result very quickly, it looks more or less exactly the same, right? We have that. But if we, for example, go on lighting only, it's just a projected shrink wrapped square now, and all the magic is happening on the material side. So if I maybe go on the wireframe, as I said, this has a little bit more resolution, but we could also try to do 6 loom faces or something and then just have a flat cube here. That should work as well. And from the results, in a way, it really depicts the original with the frame being opaque and then having the alpha map baked here in the middle. And then, of course, as we have the objects in the outliner, you can always double check the actual file. Let me see where that is. I think it was stored under other assets and then under process. Yeah, there's one thing I didn't mention in the beginning. If you actually not only import something with an import action, but if you do a processing action, that stuff in the content browser is saved somewhere else. It's saved under RPD for RapidPipeline and then process. It's a different location where it saves that.
Hey, Julian, I wanted to mention
Yeah.
we're a bit over time.
Yeah.
There's one more question in the question tab too.
Yeah. Thank you, Eric. AC, you're referring to more BIM data in that case, is that correct? Or architectural design? Is that where you're coming from? Because we've seen data from that end as well. I don't have an example live here in the webinar, but I'm happy to point you guys to another example I think we have on YouTube, if I'm not mistaken. Yeah, I think that's what's meant here, correct? But yeah, also on the BIM side, we have certain workflows and the same things I'm demoing right here should work as well. Interior design, yeah. For interior design, we have seen more assets and more workflows than for larger architectural planning and or like industrial manufacturing planning and stuff like that, like plants, power plants and stuff like that. But yeah, interior design, we actually have some experience with furniture also and then like props processing. So I would say in that regard for the interior design part, all the actual interior props would really work well with workflows I showed right now here. For example, like the remeshing and the decal baking, I think for like weaker couches or something that works well. But if we're talking about the actual spaces, the actual floor plans and stuff like that, this could be a good synergy of using actually the CAD import to actually get the BIM data in and then use maybe assets from whatever TurboSquid or any other CG Trader marketplace or something, and then basically auto-optimize them with our tooling. Just throw them in the scene and optimize with our tooling rather quickly, as you've seen here. And then we can make sure that you have a high performance in the scene. And again, on the optimization end, that's why I was looking for this wire fence actually, that it actually then also performs the whole material workflow, right? It's not just the decimation. Otherwise, you could just use the normal LOD process or even nanite in Unreal. But the cool thing here is that we support the whole normal map baking and automation pipeline. The baking process is a little bit similar if you guys are familiar with it. I'm not sure if I can pull it up here. I think I have my sharing bar in the way, but there is a actor merging feature in Unreal as well. It's something we tested. It's quite cool. It somewhat does what it promises, right? It bakes stuff together. You can actually do that with our tooling as well. So if you have multiple objects in the scene, just showing some plans here as well, and you just selecting multiple ones, you can actually then create, for example, the decimate or remesh and bake option and bake them all together in one atlas. So it's basically the same thing as the actor merging tool. And yeah, from at least our experience with the first tests, our unwrapping and stuff is a bit more from what you would expect from the artist side, given that it's an automated process. So yeah, for example, what I showed here, this is the live unwrapping and baking, alpha baking of that fence. There was no UV before, nothing before. It was just a kind of a mesh with some material applied. So this all happened rather quickly. Yeah, and then respecting the time, let me try to hide the, not the floor, sorry, the fence here. Let's see if I can select it. Yeah, and just showcasing that, yeah, we have imposter generation as well. This is a very common workflow. So if I put the lighting on, this is the version we just produced with the imposter generation, which right now is always imposter cloud based. So it's best for foliage. Right now, we don't support the billboard style and the very simple two quads projection yet, but that's definitely something we're having on the roadmap. Right now, it's creating a cloud of quads, and you can specify the number of quads. So you could be lucky with just 3 quads, right? That they are positioned correctly, but they're actually going along the original mesh and the normals. So it could be that it's not perfect with 1 or 2 quads, but usually with more than 100 quads, and we have a cloud-based approach here. It always works great for foliage specifically. So just to showcase the input here, let me see if I have it. So this was the input model. Let me try to do a little wireframe here. So where every single leaf is actually modeled out. And then what we basically get on the imposterized side is just basically the same look, but just rendered on and baked with the alpha map on the quads. And I think that goes also along the interior design part a little bit. If you have plans and stuff, and you really love certain items from online marketplaces, but they're just too heavy, and maybe the artist worked on it on a kind of a V-Ray pipeline for rendering and really didn't give much about baking it on quads, you can actually do that with our software here as well in a fairly quickly and turnkey way. And yeah, for that, we also have a YouTube demo actually of a whole restaurant scene where we're using all these tools I showed today, basically in conjunction together. So yeah, it should be available on our YouTube page for RapidPipeline. All right, I think we're over time, maybe already 13 minutes, according to Eric. Thanks again for chiming in. I hope I could answer most of the questions. And if you have more, I think on our webpage, we have a contact formula as well. When you sign up, and on the platform, you can create a ticket as well to just let us know your feedback. Of course, we're looking forward to that. And yeah, for now, I would say thank you so much for your attention. And this was really fun. And I hope we see and can do it again soon with maybe a different platform, maybe a different workflow. Of course, would love to revisit Unreal anytime. Thank you a lot.